Hi, welcome to this demo of IBM Spectrum Protect version 8.1.11. In this version, we introduce the ability to do a Spectrum Protect metadata catalog backup, also known as a backup DB, to the Google Cloud storage. Now, we initially introduced this feature in version 8.1.10 for Azure and S3 clouds. And in this demo, the developer Jimmy Fagan is going to be walking you through how to use the command line to create the cloud connections and a cloud device class, and then do things like SET DBRECOVERY, back up the Spectrum Protect metadata catalog, and then he'll go through a couple restore scenarios, including one in which he loses the Spectrum Protect volhist files and devconfig files, and another one where he loses the Google key file and has to re-download it from Google Cloud Storage. So with that, let's get started.
This top screen is just the admin client, so that's where we'll be issuing our commands and seeing our query output. And then this bottom is our server. This will show us what the act log is showing as we go through different things. Before we start, just want to show some of the setup stuff on the server. Specifically for Google, we have the key location. It can kind of be anywhere in the directory structure, and you'll just have to know where it is before you define your Google connection. The one we'll be using is the C8A for JSON. You see that that's there before we start any of this. And I've just made note of that location separately so that when I define my connection, I'll be able to use that. I'm going to start the server. That's ready. Now I'll start issuing some commands on the admin client. First off, as it was for the other cloud types, the first step is to define the connection. So define connection, Google connection. Cloud type is Google. And then we just have to give a key location, which is that location we just saw. And then we just need to give a bucket name. This bucket needs to already exist in the Google object storage. So we won't be creating that through the server. That has to exist separately so that all of the different options and things can be configured by the user rather than us guessing on our own. That all looks good. I'm going to go ahead and hit enter, and we see that that connection is defined. Next, we can query the connection. For Google, we don't need a cloud URL or an identity. All that information that we need is contained within the JSON key file. So those appear blank here. We can also do queue connection with f equals d, and that shows the location of that key file. We can do validate cloud with connection equals our new Google connection. And we see that the credentials were verified. So that all looks good. We're ready to move on to defining the dev class. So define dev class, I'm going to call it Google devc with a dev type of cloud, and all I have to give it is that connection. Okay, so our device class is defined. We can now do a query dev class. We see that it shows up as a cloud device type. We can also do queue dev class with d. Okay, so now that that's all set up, next is to set our DB recovery to set the defaults for a database backup on the server. So we're going to do SET DBRECOVERY, give it our device class that we just defined, give it the password for encrypting the master key file, and then num streams, which is 1 by default. If we want this to run a little bit faster, set IR, and the specifics of that will kind of depend on their environment. I'm going to do 4 just because I have kind of a small system here. I don't want to overload it. That's about all we need there. So that's all set up to kind of set our defaults for our database backup. Next is just actually issuing the backup DB. So backup DB, we have to give it a dev class again, and all of the other stuff will be the defaults from the SET DBRECOVERY. On that SET DBRECOVERY, there's some other options. Basically, there's options for encryption. It's encrypting the database through DB2's encryption. Then there's also an option for compression. It's one or the other, so you can't set both of them to yes. You could set both of them to no if you wanted. And then there's other various options that are all documented in the Knowledge Center. But basically, if it's a cloud backup, it's going to be encrypted by default, so you don't really need to specify anything else if you're happy with those defaults. Now, backup DB, we'll issue that. We see down here in the act log that things start going. See that we have these 4 volumes that get opened, and we're going to be writing to those. If we do a queue process, our current output volumes are those 4 volumes. At this point, we wait for that to finish up. So at this point, we're starting to see some of the volumes close. Okay, so I was just waiting for writing the configuration files. So we see that as part of the backup, the volhist, the devconfig, and the encrypted key files were all written to that subdirectory in the cloud. Those are needed for the disaster recovery, which we will show. Okay, so at this point, I'll halt the server and start looking at the restore side of things. If we wanted to restore under normal circumstances, where we have our devconfig and our volhist still on the file system, we can kind of show where those are. We have the devconfig and volhist there. We still have the encryption keys as well in our instance directory here. That is the dsym keydb files. So we have all the stuff we need to do a regular dsym serve restore. Also have the key there. So we have everything we need. So we can basically just go dsym serve restore db, and then I'm going to issue the password on the command line, but you can also just say prompt equals yes. You can go prompt equals no. This is what you would do under normal circumstances, and it would restore that backup that we just did. This is all I would issue right here. Alternatively, if you don't want to issue the password there, you could just say prompt equals yes here, and then issue that, and then it'll prompt you for that password. So alternatively, if we are in a disaster recovery scenario where we don't have those, to mimic that, I'm going to just remove SP volhist, SP devconfig. So we don't have those anymore. If we were to do that, dsym serve restore db with password and prompt equals no. So this is the same command that would have worked before. If I do that now, we'll get a failure based on no device configuration files could be used. So it didn't find that on the local server. And it also prompts you, if you want to download that from your cloud environment, provide your cloud credentials on that dsym serve restore db command. That's kind of the next thing that I'll do here then. Again, I'll do dsym serve restore db. I'm still going to give it that password to decrypt the master encryption key. Prompt equals no, since I'm issuing the password on the command line. Cloud type equals Google. I'm going to tell it where to find that devconfig volhist file, so it'll use those. I'll give it my key location. This key location is still, I guess, like for the purposes of this, just suppose that I still have my JSON file. If not, I can create a new JSON file and point this one to it. Really, you just need this key location to be a JSON file that has access to this bucket. So key location, srv drum tech. I'm just gonna copy paste the rest of this. And then bucket name equals the same one that I did before. So this is pointing it to the cloud directory where I have the backup along with those configuration files. So it's going to download those configuration files from the cloud and then proceed with the database restore from there. What we'll see when we enter this, I had a couple different servers write backups to that same location. We see to resume database restore operation, specify subdirectory in the cloud storage. The one that we were working with today was demo server. So I'd issue 1 and press enter, and it'll download those from the cloud. So we don't have to wait for that one. I'm going to instead press C to cancel and issue that again. If I want to avoid that prompt, there's also the parameter server name. So if I know exactly what server name I want to do and I don't want to wait for that prompt, I can specify it here and it'll just go right into that subdirectory. Everything the same as before, but with server name equals demo server. And when I issue this, it'll go forward with the database restore. We see that we copied the devconfig and the volhist from the cloud storage to those. We also renamed our existing encryption key files, and then we got our master key from the cloud again. This was just because we had those master key files there that they got renamed, but in general, it's downloading the devconfig, the volume history, and the master key from the cloud location. Since it had all that, then it proceeded with restoring from our volumes. We had 5 volumes. We wrote 4 volumes at a time. We had a 5th volume based on the size of our backup, but we see that we're restoring based on the number of volumes that we had out there. So it opened those input volumes and it's proceeding with the restore. Once this finishes, I'll show what it might be like if our key location wasn't on the server anymore. Finally, the roll forward completed, and now it's stopping. Successfully restored on that one. Now to kind of mimic what would happen if the key location was gone, I think I'm gonna just remove our volhist devconfig, but now I'm also gonna, I guess I'll move the key file. I don't have that original key file that I was using in that directory anymore, but I instead do have it in new keys. Now, if I was trying to do that same disaster recovery scenario, I wouldn't issue the same key location because it was no longer there. So instead, I'm going to use that new key location and same bucket name, same server name. So basically, I had my key location protected somewhere else, or I generated a new one and I have it at this location. This still has access to the bucket, and by issuing this command, I'm still going to grab the devconfig and the volhist from the bucket. We'll eventually see that this ends up failing, and the reason for that is when it gets the devconfig, that devconfig still references the old key location. It's again copied to that location along with the volhist, and then we see the encryption keys get downloaded as well, but we'll see that it fails once it starts trying to access the cloud based on the devconfig. Basically, yeah, it's finding this invalid key location here in our devconfig file. And we see that the server can't authenticate because the key location file specified in the dev configuration file is inaccessible or missing. So find the key file and move it to the location specified in the device configuration file. I'm going to move that key back to where it says in the dev config file. And I'm going to move that to code srv to match what we had in here. And then if I needed to rename it, I'd also rename it to that. I can try that again. This time, since I've already downloaded the configuration files I need, I can just do dsm serve restore db password equal password and prompt equals no. So we'll have to download those config files again. And we see that it's resuming as it did the first time. So if you don't have the key location in the file referenced by the dev config from the cloud, you'll need to move that JSON file to that location and then just reissue the command and things will go as normal.
So in summary, this demo has showed you how to use the command line interface to do a Spectrum Protect database backup and recovery from the Google Cloud storage. Thank you.